Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Muhammad Irfan, kelas 12 KA2, absen 21. Di sini saya akan menjelaskan unsur hafnium. Di sini saya akan menjelaskan pengertian dari hafnium. Hafnium adalah unsur kimia dalam tabel periodik yang mempunyai simbol Hf dan nomor atom 72. Logam transisi ini mempunyai sifat kimia yang mirip dengan zirconium. Hafnium dipergunakan sebagai campuran alloy wolfram pada filamen dan elektrode, dan juga memerankan sebagai penyerap neutron pada pembangkit listrik tenaga nuklir. Selanjutnya, sejarah hafnium. Beberapa tahun sebelum ditemukannya unsur ini di tahun 1932, diperkirakan muncul dalam berbagai jenis mineral sesuai dengan teori Bohr. Unsur baru ini diasosiasikan dengan zirconium. Akhirnya unsur ini berhasil didefinisikan sebagai zircon dari Norway. Dengan analisis spektroskopi sinar X, ia dinamakan sesuai dengan kota di mana unsur ini ditemukan. Kebanyakan mineral zirconium mengandung 1-5% hafnium. Hafnium pada awalnya dipisahkan dari zirconium dengan cara reduksi berhubungan. Aluminium atau barium fluorida menelpon mulai desain dan jenis. Berikut video pembuatan dari unsur hafnium.
Hello everyone! In this video, I would like to tell you about the most recently discovered non-radioactive metal, that is, about hafnium. If to look at the periodic table, you will see that hafnium is located at the bottom of the group 4 along with zirconium and titanium. It is there not accidentally, because all of these three metals share common chemical properties, especially zirconium and hafnium. That is the reason why hafnium is usually found combined with zirconium in rocks. For instance, in such minerals as zircon, where hafnium concentration range from 1 to 4%. The striking resemblance of this element with an atomic number 72 to zirconium was the very reason why it was discovered only in 1923. It was named after Latin name of the Danish capital, Hafnia. Here you can see the reagents and also obtained metallic hafnium, which George G. Hevesi, the discoverer of this element, used in his experiments. Pure extracted hafnium is a silvery, malleable and quite heavy metal, the density of which is 2 times that of zirconium. Because of its rarity and the challenging process of separation from zirconium, the price of 1 gram of hafnium is quite high, amounting to $10 per gram. By the way, in the last 10 years, the cost of hafnium has increased significantly because of the Fukushima nuclear disaster. After the nuclear disaster, the Japanese government shut down all the power stations in Japan, which reduced demand for zirconium used for constructing nuclear reactors. Since hafnium is extraction byproduct of the production of highly pure zirconium metal. Reduction in the production of zirconium led to the deficit of hafnium and thus to its surge in the price. It's very hard to separate hafnium from zirconium because of the close resemblance of their chemical properties. That is why only recrystallization from hafnium chloride can be used for purpose. Nowadays, separation of hafnium from zirconium is a very important process, because highly pure neutron transmissive zirconium is essential for the manufacturing of fuel assembly. Hafnium, on the other hand, absorbs free neutrons very well, and because of that, its traces in the zirconium tubes may interfere with the reactor's work. Hafnium can be used for regulating the speed of chain reaction in reactors, and it also can be used in control rods. From a chemical point of view, hafnium is almost a twin brother of zirconium and is not very likely to impress you with its chemical activity. This metal almost doesn't oxidize when exposed to air, but when heated up, it covers in a thick dark oxide layer, just like zirconium. Like this piece cut off of a bigger chunk once did. Just like zirconium, hafnium produces bright sparks when rubbed on a file. However, they are seen even better when a piece of hafnium is ground against or grinding wheel. The small particles produced burn up in the air at a very high temperature, more than 2000 Celsius degrees to be precise, which produces very bright sparks. If hafnium powder is burnt with a burner, this process can be observed even better. When hafnium burns up in the air, what's produced is nothing but hafnium oxide, which can then be used to produce the most refractory material on Earth, that is tantalum hafnium carbide, with the melting point more than 2000 Celsius degrees. In the future, such materials can improve the properties of rocket engines, or increase the temperature of plasma in fusion reactors, but those are just my suggestions. Hafnium almost doesn't dissolve in concentrated nitric or hydrochloric acids, but in hydrofluoric acid. This metal starts losing its inert properties quite quickly, and similarly to titanium, starts dissolving very quickly, forming a complex compound that is hydrogen hexafluorotitanate to be precise. And yes, I'm running this reaction in a plastic cup, because hydrofluoric acid will damage a glass one. During this reaction, dark oxide layer disappears off the surface of the metal, which makes the hafnium exposed shiny again. Upon adding of alkali to a solution of hafnium complex, a white precipitate of hafnium hydroxide will form, because almost all hafnium compounds have white color. Just like zirconium, hafnium is well for running color anodizing. The process then can produce beautiful and quite expensive jewelry. Nowadays, hafnium is mainly used for manufacturing control rods in some nuclear reactors. Mostly those are research and military models through. This metal is also added to heat-resistant alloys, for instance to those used to manufacture rocket engine nozzles. It's quite expensive to use hafnium for other purposes. That is why whenever possible, it is substituted by the cheaper zirconium. Modern nuclear physicists also are trying to discover another extraordinary application of isotope of hafnium-178. The thing is, excited atoms of this isotope can also emit X and gamma radiation under the influence of external forces, for instance, such as alpha rays. Just like luminophores emit visible light under the influence of higher energy UV rays. If a piece of hafnium-178 is exposed to the radiation, this isotope will unleash radiation, which is 100 times more efficient than chemical reactions. This process can help create extremely efficient nuclear reaction engines and also more precise radiometric devices. Since I am not very good in nuclear physics and can make mistakes, I will leave a link to an article about this topic in the description. Finally, we can say that hafnium is a very unique and interesting metal. However, due to its high price, it is not very common in our everyday life. For the provided hafnium and zirconium pieces, I'll thank the company Stanford Advanced Materials. I'll put a link to their site in the video description. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting